It's a pleasure to be here to speak to you today. I'm going to talk about Scala. Best time to ask a question or make a comment is when you have it, so please don't wait till the end. Anytime is a great time. And if you do have a question or comment, draw my attention. If you're raising your hand, I may not take note of it, so do yell out or draw my attention, and I'll be more than happy to listen to you. So let's get started. We're going to talk quite a bit about Scala, and what I'm going to do here is to write some code, play with some examples, and then if you have any questions, we can kind of go in that direction as well. So the first question, of course, is why should we look at something like Scala? The number one reason is it's fun. Do you need any more reason than that? That's it, right? So it's a lot of fun to program in a language like Scala. What drew me into Scala was I'm pretty much I really like languages, and I started programming in C#, coming from C++ background, Java, C#, and traditional languages like that, mainstream languages like that. But then along the way, got excited about other languages like Ruby, and then kind of went on to program with Erlang. And as I was kind of getting excited about Erlang, got really excited about the actor-based concurrency model in Erlang. And then when I turned around, I looked around and said, well, this is kind of interesting. Scala gives you the Erlang's concurrency model, but on the JVM. So quickly I got drawn into it, started playing with it. And of course, Scala gives you some of the really interesting benefits of functional programming. And so let's talk about what are some of the things that Scala can do for us. Scala is, first of all, a statically typed language on the JVM. So if you are writing code in Java, you have another option to look at is to program in Scala. It's a language on the JVM. It's a statically typed language. I don't think it's good to say Scala is statically typed like Java, because it's more statically typed than Java is. And as we will see in a few minutes. It is a language which is hybrid functional language. What that means is that could be a good news and a bad news, depending on how you see it. It's a language which gives you the functional style of programming, but at the same time, it doesn't force you to do so. So it's kind of like a dial that you can turn all the way to the left, and you can write imperative code like you are used to in Java, or you can turn that dial all the way to the right, and you can write functional style code like in functional languages, for example, in Erlang and other languages. So let's talk about some of the things that we can do with Scala itself. Well, first of all, Scala is a functional language in that regard. And what does that mean? How does it really feel like doing it? So let's take a look at an example here. Let's say for a minute that we have a list of values that's given to us. We'll call it numbers, for example. And I'm just going to start with a bunch of numbers, let's say a handful of numbers. Now, suppose I want to total these numbers together, or maybe I want to double these numbers together, in this list and do operations on it. We know how to do this in an imperative style. So let's take a look at an example of totaling these values, for example. So we could say var total equal to 0, and of course, when I'm done with it, I want to simply print the value of the total. But how would I start totaling these values? We could say for, and then I is going to be values within the numbers. So this is like your traditional for loop in Java, or the for each loop in Java. You would probably say for int I colon numbers in the case of Java to write this, isn't it? And then of course I would say here total plus equals, and then I would specify the value of I, or if you want to call it as an element, you can call it as an element E as well. So you could write something like this and ask it to total the values. Now in this particular example, as you can see, it did tell us the total is 21, but this is a great example of a very imperative style of coding. Now, what is the smell of an imperative code? There are two things we can look at in an imperative code. The first thing in an imperative code is you kind of have to tell the code every step of the way, not only what to do, but how to do it. So in this case, of course, we told him to loop through each of the values, and then of course to total each of the values. The second smell of an imperative code is the mutability of a variable that you see here. So if you notice on line number 3, we declared the variable as var, meaning it's a variable. And then, of course, we are constantly modifying this value in the loop. So that is an imperative style of coding as well. In a functional style of coding, we lean more towards a declarative style of coding rather than being imperative. In other words, rather than telling how to do certain thing, we focus more on what result we want to achieve, and then simply let the code take care of how to implement it. So a more declarative style of coding is easier to write, much more easier to, more expressive, obviously, for us to say what our intent is, and then it becomes a lot more easier to work with. So how would this look like in a more of a declarative style of coding? The other thing, of course, in functional style of coding is we would normally eliminate the mutable variable. So rather than mutating this value over and over and over, we would program with no mutability. Now, of course, at first thought, that may appear really strange. How could you really total values without really mutating any variables at all? Well, let's think about this with somewhat of an experiment. Let's say that I want to total everybody's age in this room, starting with him. No, he's really grim. No, I'm not going to ask for your real age, no. So we're going to total everybody's age in this room, let's say starting with him. But let's say I have a special post-it notes. Now, the post-it notes are special in that they are write once post-it notes. You can write on them once, but you cannot erase them, you cannot rewrite on them, you cannot overwrite on them. So on this post-it note, the first post-it note I tear off, I put a 0 on it. Of course, I cannot change it now that I've written 0 on it, and I'm going to give it to him, right? So what's he going to do? He's going to take his own age and then add to the value of the age on the post-it note, which is 0, and then comes up with this number. But wait a minute, he cannot change the post-it note. What are his options? Any ideas?
New post-it.
A new post-it note. Why not, right? And so he's going to tear off a new post-it note and write his age on it plus 0, and then passes it down to the next person, right? So what does he do? He takes the age from the person on his left, adds his own age to the value, creates another post-it note and passes it down. And of course, eventually what I get from the last person in the room would be the total of everybody's age in this room. Making sense? So notice in this case, we didn't mutate any variable. Of course, one small concern you may have is, gosh, we kind of tore off so many post-it notes. Well, remember one thing about Java, it's got fairly good garbage collector in place. And maybe we could also figure out a way that this can be more efficient somehow. That's a second problem to solve, right? Premature optimization is the root of all evil. Let's not worry about that problem right now. So the point is that we could be creating these new values and not change existing values. Well, let's kind of put that in code and see how that would feel like. So I'm going to rewrite this code to total. But this time, notice what I'm going to do here is I'm going to start with the numbers given to us. So numbers is the value that I've taken. And I'm going to call a method called foldLeft. And I told that I would pass a 0 as the initial value. That's the value that I'm going to give to him. And I'm going to pass to it another little value. We'll see what this is in a second. And this is going to take 2 values in here. I'll explain what this means in just a second. And I'm going to ask him to really total these values together and then represent the value. So notice that it produced exactly the same result as the previous one. But what did we do here? Well, first of all, notice we did not mutate any variable at all in the second expression we wrote. So what is foldLeft doing? It somewhat does exactly what I explained. We start with the initial value of 0, but to this function, we are giving 2 objects. Now, the first object we are giving to the foldLeft method is the value 0. That's kind of obvious here. But we are also giving him another object. This object we are giving to him doesn't quite look like object in our eyes, but this is actually a function value, or that's what Scala calls it. A function value basically is nothing but an object that represents a function itself. So in other words, the foldLeft method really took 2 parameters, 0 being the first parameter, and this function being the second parameter. In other words, in functional programming, we kind of do to functions what we normally do to objects. So like we can create objects within functions, we can return objects from functions, and we can pass objects to functions. Now we can create functions within functions, return functions from functions, and also pass functions to functions as well. So in this example, we created a function right here, an anonymous function. We call it lambda expressions, and then we pass that function to the foldLeft method. So the foldLeft method said, I'm going to start with a value of 0 to begin with, and then I'm going to call this particular given lambda expression or function value, and then it binds the variable c to the initial value 0 we gave, binds the variable e to the first element in the collection. This is as if he's taking his own age, which is e, and the carryover, which is c, the value given to him from the left, totals those 2 up and returns it. The foldLeft method now invokes this function one more time, but this time binds the variable c to the value given from the previous call to this function, and the element E is bound to the next element in the collection, and the sequence continues until the end result is obtained, which is the total of all the values. Now, in this particular case, we are expressing a little bit about what we want to achieve, and we let for left really do the iteration itself. So we didn't quite write the iteration. The iteration is implicit in this regard. And then, of course, we told him we want to fold everything together and give us the result. So it's more declarative in nature because we told an intent rather than a particular set of actions to perform. The other benefit you see here, of course, is that in this particular case, we don't have any mutable variable at all. Let's step back for a minute and look at yet another example of this. How would this look like? Let's say for a minute you're writing Java code. Let's just imagine that for a second. And when I say Java code here, of course, I'm talking about pre-Java 8, because a lot of what I'm going to show you here, Java 8 can do that as well in terms of functional style of coding, and then we'll deviate and look at things that Scala can do, but most likely Java won't do in Java 8 as well. But looking at pre-Java 8, how would you double each of the values within this collection? Well, let's think about this for a minute. If this was Java code, what would you do? You would first say list of integer, and then you would say doubled equals, and then you would say new array list of integer. Using Java 7 notation, we don't have to put integer over there. And then you would write something like for int I, or element in numbers, and then you would write something like double.add, and then you would say value E times 2. And then eventually, when you're done with it, you would output system.out.println, for example, and then you would output doubled over here. That code won't run, obviously, because it's Java code, not in Scala. But does that sound familiar? Anybody here who's written code like this before? Yeah, one brave person raises the hand. One more. People are slowly in denial, right? I fully understand, right? You don't want to raise your hand in public for that, especially with the camera around. That's fully understandable. But once you write code like this, how do you feel? Dirty, isn't it? Right? You feel really dirty. You go home and the kids come running to you, say, don't touch me, I got to go shower first, right? Because you spend the day writing code like this. There's a name for this, by the way, and that's called primitive obsession. And we have primitive obsession when we code in languages like this because we work at a very low level of detail. That takes a lot of effort, and we rinse and repeat, right? That takes a lot of effort. But notice what's wrong with this code. This is very low level, it's very imperative, and you had to spell out every single detail to him. Imagine speaking this out and how tiring it becomes. Go ahead and create an empty list for me, please. Now start looping through every value. Double the value first. Add it to the empty list I created so that you can keep adding to it, and then repeat this, right? So notice how low level we had to go through to do this. Well, we could do this in a much higher level, if you will, of a level of abstraction. So how about simply saying numbers.map? So what is map? Map is a function that simply says, I'm going to apply a mapping operation. This comes from a mathematical term that we perform transformations, right? Now, if you think about this, this makes a lot of sense because a lot of things in life applies this transformation. We got signals coming in and we transform the signals. You may have a little camera that may have lights coming in. You transform the light as it goes through. So a lot of things kind of fit into this really well. And what do I want to do for the mapping? Given an element on my hand, I want to double each of the elements and then return the resulting collection out of this. So we focus more on what we want to achieve than sitting there and spelling through every bit of the detail. And also notice there is no mutability in this example. So what we have done in this case is we've said numbers.map. And so we apply this map operation, and then we said the operation we want to perform on every element in this collection is this doubling of the values given to us. So that's what we have said here in this particular case. And so if you focus on this for a minute, map is a function, but the map function itself is being called on the numbers collection. But notice we are passing to it a function itself. Now let's focus on this highlighted code for a minute. Now, what is a function? For most of us, we would say a function has four things, right? A function has a body, a function has a name, a function has a parameter list, and a function has a return type, right? So body, name, parameter list, and return type. Of these four things, which you think is the most important? The body, I hope, right? Without it, there's no point having this function. Well, right here is the body of this function. Right to the right side of the arrow is the body of this function. So you can see that The body of the function is right there, so 1 down, 3 more to go. Hey, what about the parameter list? The parameter list is to the left of the arrow. Well, generally speaking, we would provide the parameter list with the types of the parameters and the variable names, isn't it? So we could, in general, in this case, we could say int like this, and then we could write code like this. As you can see, it still works. So, but on the other hand, we don't have to waste that effort in Scala. We can leave out the type information. I'll talk more about this in a few minutes. So right there is the type, or the parameter list rather. So we have this arrow separating the parameter list on the left side and the body of the function on the right side. So 2 down, 2 more to go. And then, of course, you say, what about the return type? Well, the return type is inferred in this case. We don't have to specify it. And what about the name? Who cares about the name? It's anonymous function, so we don't have a name for it. Go ahead, please.
Is E a keyword, or it could be R or V?
Right, so the question is E a keyword? And the answer is no. You could call this anything you want to. That's a great question, by the way, because this is one of the complaints I've heard quite a few times from people, is to say that functional code is hard to read. So don't be under pressure to name this as E and P and I. Feel free to give it a good name if that makes sense to you. Absolutely give a descriptive name. And I often tend to do that when I write code for production. I do give more sensible names depending on the context of what it's supposed to do. So absolutely give a good name for the variable. And so that's just a placeholder. Just like a parameter to, in fact, you are writing a function. So functions do have parameters, and whatever names we can give legally to the parameters, that's basically what we are doing here, element being the legal name we are given for the parameter. Really good question. Absolutely give good descriptive names for those things as well. So we looked at how we can write a function, and this anonymous function we wrote is being passed to this map function in this particular case. And what does a map function do? The map function, by the way, is an internal iterator. Now, in general, in Java, we are used to using external iterators. So what's an external iterator? External iterator is like a rude dog that's also lazy at home, right? So you say move, and it kind of looks at you. And you have to kind of move it, and every step you have to move it, and it just stops where you move it to, right? Whereas an internal iterator likes throwing a frisbee at the dog, right? And it immediately goes, gets it. So you don't have to spell out the detail. You kind of express the intent. So an internal iterator basically says, I am going to take care of the engine of the looping, and as a result, you don't have to focus on the looping, but instead focus on what you want to achieve for that particular element. By the way, you can do this in Java 8 as well, very, very close to this syntax even. But why do we want to go this route? Now, remember, if you look at this particular case, it feels like we are losing a little bit of a control. And by the way, that's a good thing. And the reason why it's a good thing is because we are not spelling how to do things, we can employ polymorphism, meaning I don't want to tell you how to do, so you can figure out how to do it. So the map function can all of a sudden say, hey, looks like this operation can be done concurrently. Why am I sequentially evaluating each of the elements? I can distribute this across multiple threads and have them run concurrently. If it so chooses to do it, absolutely why not make use of it? So the internal iterator can take control based on the context and decide to do things on its own, depending on whether it should run it sequentially, run it concurrently, or other flavors as it may make more sense. So we looked at a little bit about the functional style and how that can work together. But let's get back to Scala and talk about certain things that are kind of unique to Scala when compared to Java itself. One of the things that Java provides is static typing. Well, what does that mean really? Well, if you're writing code in Java, how would you write it? You would say, for example, list integer, and then you would say, of course, something like values equals new array list of integer, and you would have to specify these things in the older version of Java. In the newer version of Java, in Java 7 at least, you can let that go, right? But every step of the way, you have to tell what the type is. And that can become pretty annoying, right? A lot of times we specify the type, and it's kind of like you know what the type is, the compiler knows what the type is, and yet you have to spell it, right? It's kind of like going through the TSA every day. I do this all the time. It kind of gets tiring after a while, right? It's like, dude, if I want to be a bad boy, I wouldn't be here doing it, right? So that's the whole point. It's like you know what the contract is, but why do you have to keep spelling it over and over and over? That kind of becomes painful, isn't it? Well, in the case of Scala, by the way, you don't have to go through that length. Let's take a look at an example. So I'm going to say here, say greet string equals hello. And I'm going to go ahead and print this greet over here. So let's go ahead and print the greet string that I wrote. So it just prints the value greet, all right. Now I'm going to say greet over here. And let's say this is going to be howdy over here. I changed the value. And I'm going to go ahead and print this as well. And as you can see that I was able to change the value and print it. But what if I say greet equals 1? Well, notice how we get a compilation error. It tells me very clearly that the code will not compile because, and it's not a runtime error by any means at all. It's a compile time error. It didn't run through the first half of the code and then stop and say, oops, right? It gave us a compilation error saying, I'm sorry, I cannot run this code because down below here, you're violating an expectation, a contract. So you cannot assign a value of 1 to greet because greet is a string. Now, having done this for a minute, let's go ahead and remove this code from here. And let's get back to this code. And I'm going to remove the colon string from here. Now, when I got into Scala, when I was new to Scala, I first read that Scala is statically typed. So I started putting type information in my code all over. And it took me a while to realize I was totally wrong. So one morning, I ran to my computer, and I removed the type information. And I ran the code, and the code still ran. And Scala was kind of smiling in the background saying, kid, you finally got what this is about, right? So the point really is that Scala is statically typed. In fact, it's more statically typed. And that means you have to do less typing with your fingers. Because the language is a bit more intelligent, it can figure out what the type is. So we don't have to be typing the information with our fingers all the time. So as a result, as you can see now, I can go ahead and change the value of greet one more time and print it. That works fine. But make no mistake, if I say greet equals 1, we get exactly the same compilation error we got a few minutes ago, because on line number 1, Scala was able to infer at compile time that the variable greet is of a type string. Of course, when you look at that code, that's kind of obvious it's a string, right? What else could it be, right? So, and so it says I'll infer the type. So Scala does a fairly healthy dose of type inference. And the only times it doesn't do type inference is when the type inference can either be ambiguous or a bit confusing. And I think Scala has a very nice balance. If you program in a language like F#, I feel that they actually push it a little bit further, which to a scary point, where they would walk into a function implementation to explore the type and then decide what the parameter types are. Which can be a little kind of scary, right? Because if you change the implementation of the function, the type can have a different meaning all of a sudden, and that could have other impacts. So Scala says, I'm not going to go that length to give you the type inference. So Scala will infer the type wherever it can. So for most part, the places where you have to specify the type is when you are defining parameters to functions, for example. You would also have to specify the type when you declare members of a class, for example. But for most of the other times, you don't have to specify the type. In fact, I would say don't put the type, let Scala complain, and then start putting the type when you do need to. But of course, you need to give really good variable names, obviously, because without the type information, you really need to convey things a little bit more. But of course, if we have a team which is going to give variables with letters like A and B and C, this is not going to make it any better. So it's not going to make bad code better. It actually makes good code actually better in a way. In fact, if you notice in this case, in the case of Scala, you specify the type right in the reverse order than you do in Java. And the reason is Scala says it's more important to give a good name for a variable than to specify what the type is. And that's why the type actually comes after the variable name in this case. Please. A really good question. So the question is, in Java, typically I would define a list as a variable type rather than an array list as a variable type. On the other hand, here you're letting this to type inference. How does that work? Well, let's think about this for a minute. If I am creating something as a list or an array list, and if I'm only using it within a function scope itself, it really didn't matter what we declared it as, because it's still going to be treated as such. The real essence is when we start passing this out to other functions, what have you. So the same concepts appear here as well. When you're passing something, it will know what type to send it to. So within your encapsulated code, it's the type that infers it to, maybe more specific to the type you create. But when you pass it, the contract actually comes in, and then that's when the real contract type gets in. So that is why in the case of function parameters, you still have to say what the type is. In that case, you would say that it's a list and not an array list, for example. Whereas within your body, it really doesn't matter which way we specify, because that has no repercussion outside of the scope of this particular code. The question is, are objects passed by value? It makes absolutely no semantic difference between Java and Scala. They're exactly the same way as in Java, passed by reference in that regard. So they're not copied at all in this case. So Scala doesn't change the semantic meaning of the objects in any way. It still behaves like the way Java behaves. Because Scala compiles down to byte code and then runs on the JVM, you can intermix Java code and Scala code back and forth. So you can write some code in Scala, some code in Java, and call back and forth if you wanted to. Not that I would recommend every alternate class to be that way, but it gives you the ability to go back and forth, so it doesn't change the semantic meaning. Right. So the question is, how does it deal with when you do send a particular type? The answer is it is exactly like the way in Java is. You can only send by only compatible types, for example. So if the type you're receiving is a base type, you can either send a base type or a derived type, but not the other way around. In other words, the covariants are definitely handled in Scala like in Java is. Yes. So the question is, the greet appears to be mutable here. I haven't gotten to the immutability part on this one yet, so stay tuned. I'll talk about that in just a minute, please. Can you say var greet without giving any value to it? That's correct. You cannot do that. You cannot. And the reason is type inference says, I'm sorry, I'm clueless at this point. I don't know what you're referring to. Give me more details at this point. The time when you can, actually you cannot say that. If either you have to bind it to a particular value from which it can infer the type, or you have to specify what the type is.
So say var greet :string.
That's correct. And then in that case, of course, you're saying, I'm going to come back and give you the value later on. And Scala is like, all right, I'm happy with you because you're going to give me the value a little later on. But if you're not going to give me the value now, give me the type. Yeah, absolutely. Excellent. So we looked at the type inference, but let's talk about vals and vars for a minute. Now, when it comes to variables versus values, now we all kind of have programmed in Java for a long time. We have done mutability all the time. And mutability is something we do without even thinking twice. However, if you have a mutable variable, that kind of is a little shaky. Things change. And when things can change, there's a more opportunity for introducing bugs in the code. Now, when it comes to sharing, sharing is a good thing, right? Remember what mom told us, right? Sharing is a good thing. But mutability is what we do, and sharing is a good thing. But shared mutability is devil's work. And the minute you bring shared mutability, all kinds of things go wrong in code. Now, if you're writing concurrent code, and even if you're not writing concurrent code, if you're just writing code, avoiding mutability as much as possible is a good thing. Now, this is great. We can all agree to that. But how do you do that in Java? Well, the effective Java says, as much as possible, make all your variables final. Well, great. I'm going to mark all my variables final. But then what if I forget to mark something final? Is it possible? Absolutely, right? Because we are humans, we could forget to write final. And how do you look for where you forgot to write final? When I wrote the book on the JVM concurrency, I made all my variables final. And the week after the book was published, somebody tweeted saying, oh my gosh, I'm looking at Venkat's book. He's got 350 uses of final. I replied back saying, but you didn't realize where I still forgot to put final, right? And that's painful. In fact, I remember the afternoon before the book went to print, I said, hang on, guys, let me verify if I have final everywhere. That was the lowest point of writing that book, because I had to sit there and check where I forgot final, because I tell people make it final, and you don't want to miss out final in the book, right? Now, how do you look for where final is used? That's very simple. Grep for final. How do you look for where you forgot to put final? I'm sorry, I'm still working on the regular expression to write, right? That is a lot of effort, isn't it, to look for something that doesn't exist. Well, Scala says, stop right there. You make a decision right now. Do you want this variable to be a variable, Or do you want this variable to be a value? Kind of an oxymoron, meaning you cannot change this value, right? It's immutable. So in other words, you can declare a variable greet equals hello like this. And then, of course, you can go ahead and change this variable greet equals howdy like I just showed you before. And you can go back and change it, as you can see, and then you can reprint the value. On the other hand, if I mark this as val, if you will, then we are saying I don't want this reference to ever be modified in this code in the scope of this variable. Now the beauty of this is I will get a compilation error saying I cannot reassign a value to a value, obviously, in this case, right? So in other words, if you follow this approach, you cannot come back and say, oops, I forgot to put final. You got to make a very clear distinction whether you want mutability or not. Now comes the best part. You can easily do a code review, and I can do a very quick grep on var and say, why are we using so many variables? And as a code review, I would say, let's favor values more than variables, except when we want to use an exception. And so we can apply certain special rules to deviate from the norm and favor more vals than vars in the code. And in general, I would say when you're writing code in Scala, you do want to prefer more vals than vars as much as you can, but it makes it a lot more easier to find this. Now, quickly to clarify this, by the way, the var or val purely influences the reference itself. So think of a val as final in Java. So if I have a final string, we know the string is immutable and the reference is immutable as well. But if I say final string builder, for example, then of course the string builder can be modified, but the reference cannot be modified. The same concept appears here as well. The val indicates the reference, doesn't dictate what the object can and cannot do. That's completely orthogonal to that. And then we can make the object final as well, immutable as well if we wanted to. So as much as possible, we can favor vals. But on that note, let's talk about something for a second. Now imagine for a minute that you are writing a Java function. And in the Java function, if you say public void foo int a, and then you have some code up here, and then you say a equals 7, and you have some more code here. Now, looking at this code, we all know that this is evil code, right? Why? Because this function foo quietly is modifying the input variable provided to it. Modifying input variable should be punishable under law, right? Because that's very poor programming practice. How many times have you ran into bugs because of it? I had a guy, raising the hands over there, right? I had a guy call me up one day and said, my code doesn't work, I don't know why it doesn't work, can you take a look at it? So I'm looking at his code, and both of us are looking at the code. I'm like, gosh, this is kind of strange. Why wouldn't the code work? And then we start debugging step by step, and suddenly we realize in line number 7, he's modifying an input variable. Our eyes are so much in denial, they don't see the code in front of us, right? And then once you realize he's changing the input variable, they're like, are you changing the input variable? And he's like, oh, darn it, I didn't mean to, right? And this is really bugs creep into code. And once we figured out what the problem was, we fixed it. Now, what does Java say? Java says, well, since this is a bad practice, go ahead and mark this as final, right? So in other words, if you mark input parameters as final, that's what effective Java says, right? Make things as much final as possible. Well, but you have to remember to put the word final, or you have to use a tool that tells you to put final, right? Now, what if this is the way it will work? Let's look at an example. Define foo, and I'm going to say a is an integer. And then within this function, I'm going to just print the value of a. Let's start with this for a minute. So I'm going to call foo with the value of 4. So you can see the value of 4 printed. Now I go here, sneakily I say a equals 7. I modify it. Now notice what happened. It got really mad at me. It said, how dare you are trying to change the value of a in this code, right? Why? Because by default, the parameter to a function is immutable. Now, of course, usually people ask me, is it possible to really make it mutable? The answer is yes. Go back and program in Java then, right? So the answer is no in Scala because that's such a bad practice. They don't want you to do that. So input parameters are treated as final, and in this case, of course, a val, you don't have to really say anything related to that, as you can see, because that is the most logical thing to do. So it really favors immutability, as you can see in these cases. And in fact, you can kind of think about this for a minute and say, wait a minute, that is kind of interesting. We do want to treat input parameters as final, but why don't we do this in Java also? Well, that's why we have the book like Effective Java, right? Now, it's kind of interesting to think about Java itself when you say, here is Java. Would you hire anybody, by the way, who has not read Effective Java, right? That would be like your first interview question, right? Hey, dude, do you program in Java? Yes. Have you read Effective Java? No. Well, here's the door, right? So you want to make sure they read Effective Java. But I'm sure you have wondered one day, if Effective Java is such an important book to read, why don't they fix Java to be effective? Well, actually they did, but when they got it done, they called it Scala, right? So a lot of things, as you can see, is fixed the nice way because that's the way it should behave. So they took a lot of these recommendations and worked on it, as you can see here. Okay, that's great. Let's talk a little bit about essence versus ceremony. Now, what is ceremony, by the way? Ceremony is what you have to do before you get to do what you really want to do. And ceremony is boring. Ceremony really is tiring, right? You're like, I would much rather be doing that, but I have to do this because that is ceremony. Well, let's think about some ceremonies for a minute. Let's talk about Java for a second. Has anybody had a chance to teach Java to anybody here? Have you done that before? A few people raising their hand very quietly. That's okay, be brave, right? We all have taught Java to a few people around, right? Okay, so you decided to teach Java, and your audience is sitting in front of you and saying, I want to learn Java, but is it hard? And you said, no, Java is very simple, because every book written on Java says that, right? So it's got to be simple, right? So they say, well, if Java is simple, can you teach me something simple? You say, don't worry about it. I'll teach you something very simple. How about a hello world? And your audience is immediately like, cool, I want to learn hello world in Java. You're like, let's do it. And then you said, let's get on to it, right? And you said public. Excuse me, yes. What is public? Well, you don't need to know that right now. Okay, and the student, notes down loyally. Public, no need to know that right now. And are we doing hello world? Absolutely. Class, excuse me, what's a class? You don't need to know that right now. Okay, fair enough. Hello world, and there's a glimmer of hope in this person's eyes. Yes, we have hello world. And then you put this curly, like, what now? Right? Then you said public, and immediately the person looks at the notes. You don't have to know that right now. Awesome. Then you said static, and that's it. Is that something I don't have to know also right now? And the person is very nervous right now, right? Because I've seen 5 concepts I don't need to know right now, and this is somehow supposed to be simple, right? Now, this is called ceremony, right? Ceremony is where you do stuff you don't have to do before you get to do what you really want to do. What do you really want to do? Print hello world? Why are we not printing hello world? Why are we writing all of these stuff? Oh, let me explain to you why. That's because the JVM wants a class that has a public static void main. But that's JVM's problem, not your problem. And Java says, I'll make JVM's problem your problem. Scala says, I'll keep the JVM's problem, and I will not put it on your face. So why not simply say, hello world over here, and be done with it? So notice in this case, there is no ceremony associated with it. You say, wait a second, you said a few minutes ago that this runs on the JVM, and it produces a bytecode. How in the world could that be true? Because we know that JVM requires a class with public static void method. Absolutely true. But what Scala compiler, the Scala C compiler does is, it says, I'm going to take your code, I'm going to write a class with a public static void main method in it, and I'm going to stick your code inside of it, compile the whole darn thing, and then send it to the JVM so you don't have to do it. So in other words, Scala compiler wraps all this to meet the expectation of the JVM, so we don't have to sit there and waste our time and effort looking at stuff that we don't want to care about. So it gives an illusion of scripting, but it really is not scripting in the sense of scripting. It still is the good old Java class we are writing under the covers, and we are sending it to this in this particular case. So you can see how we have essence over ceremony. There's a lot of things that are optional in Scala. Like what? For example, you already saw me show a couple of things already. You can see that in Scala, we don't have to write semicolons. So we simply said, hello world, like this. Now, if I put a semicolon, right, it still works. But you don't have to put the semicolon. Anybody here thinks that semicolons are important? Not really, right? In fact, I got to prove that semicolons are not really a good idea. If you take a look at your hand for a minute, there's a reason why your pinky is the shortest. Because years of emotional abuse it's taken, right? All these other fingers do useful work, and then you stop and hit the semicolon. It's like, why me, right? So it really is taking an emotional, toll on it. Well, you don't have to put semicolons in Scala, as you can see. You don't have to, put that. Semicolons are optional. Parentheses is optional in certain contexts. Return is optional. So if I were to write a function, for example, so I'm going to say define foo, and I'm going to write a variable here, and maybe I want to return a times 2. I could call here, for example, foo, and send 3 to it, and we can see that it's returning a 6. I don't have to put the return keyword. So the last expression in the function is automatically evaluated, and the value is returned, so we don't have to say it. Type information is optional in a number of cases, as you saw here. It knows that foo is returning an integer in this case. How so? Because it evaluates the body of the code and says, aha, a times 2, what would that be? Well, I know a is an integer, and a times 2 obviously is going to be an integer. So it figures out what the type is based on the inference, and we didn't have to tell him that it's an integer type in this particular case. So a lot of these things are optional. Classes are optional as well, as you can see. We didn't have to write a class in this case. We just threw in a few functions together. So a lot of these things are optional. Now, what is good about having optional things? The nice thing about having things optional is you don't have to involve ceremony. And as a result, you can directly get to the essence of what you want to do rather than playing around the compiler and pleasing the compiler. So let's take this up a notch, please. So the question is, are there times when it's better to put the return type? Maybe we made a mistake on the return type, or maybe we typed something incorrect. The answer is, if you are more comfortable putting the type, don't hesitate to put the type in the beginning. And once you get really comfortable with it, you will kind of, start losing these guards around you, and you will realize that we've been overworking most of the time. So let's think about this for a second. If we write code, I used to work for some companies where the minute I write code, my boss would say, awesome, now let's ship it. But we normally write code, and we do this thing called testing as well. So if we ever use the code we write, then all these issues kind of disappear. Because I'm going to write a unit test on my code. And even in statically typed languages, by the way, I favor unit testing quite a bit. So if I ever write code that is unit tested, it is going to exercise a certain behavior out of it. In that case, the type information really is not the only validation I'm going to have, because my code is going to exercise it right away. So I'm not going to say it is never useful, but in general I feel that the compiler is way overrated than it really is. Compiler is very useful, by the way, but we seem to put it in a pedestal more than it really deserves it. So I would say down it a little notch and say, I'm going to live without it and see if I really need this behavior or this specification. And I find that a lot of times I really don't. I overwork in giving these information. So the question is, can I have 2 implementations of foo where they return 2 different values in that case? Well, that goes to the issue of contravariance, where we are trying to return a different type, and overloading rules would prohibit from that happening, because a signature of the method wouldn't tally up for the conflict to resolve. So very similar to Java, it would enforce the overloading ambiguity rules as well. So we don't have to worry about that either. But like I said, go ahead and put the type information until, yeah.
Can I declare
You can't declare.
Foo returns integer and foo returns?
No, you cannot, unless there's the overloading. As long as the overloading doesn't conflict, you can. But if that is the only difference between the functions, it would not allow you to do that. That's correct. That's correct, yeah. So let's take this a little bit further. Let's say for a minute I want to implement another thing that Scala allows, which is really nice as a compiler support. Let's look at an example here. Let's say for a minute I want to write a factorial function, and the factorial is going to take a value that is given to it, and I want to return a factorial of this number. So I'm going to say var fact equals 1. I want to return the fact when I'm done with it. So I'm going to simply print the factorial, let's say of 5 in this case. I haven't implemented this yet, so it gives me a value of 1, which is incorrect. But let's go ahead and implement this real through mutability, of course. So I'm going to say value of I within the values of, let's say, 1 to n. And I'm going to say, in this case, this is going to be fact times equals the value of I. So I have implemented a factorial using a simple iteration. Now, iteration involves mutability in this case. It is a very simple code, but we are writing imperative code in this particular case. We could have traded this with the for left method we wrote earlier if we wanted to. But let's change this a little bit. Now, let's say for a minute we want to use a recursion to do this. So I could say if n is equal to 1, I want to return 1 itself. Otherwise, I want to return, let's say, n times factorial of n minus 1. So this is a very simple recursion. Now, of course, because the function is recursive, Scala says I can go multiple levels to find out what your return type is. So this code will not compile, by the way. It will give us an error, as you can see here. And to resolve the error, you have to tell him what the return type in this particular case is. Now you can see that we wrote it as a recursion. Now, what do you think of recursion? Recursions are really awesome, isn't it? Right? Recursion is the best way to really gather up friends, right? They want to party with you because you can solve problem by using sub-problem solutions, right? How cool that is. So they want to hang out with you. So recursions are really awesome. Until there's always this one guy in the party who doesn't like you and says, what if I increase this value? Right? And then you increase the value and the party is over. Right? Why? Because we got a Stack Overflow exception. And everybody is gone, you're sitting there alone, and like, it was so cool if it only worked, right? So recursion is such a wonderful idea, but how sad it is that we have Stack Overflow exceptions. How could we solve this? Well, what if we can solve this by a little bit of a compiler magic? Now, what is this magic? There's a fantastic book out there, by the way, a book I really like a lot. It's called Structure and Interpretation of Computer Programs. And if you just Google for SICP, you will find it. So Structure and Interpretation of Computer Programs, a book by Sussman and Sussman, talk about a little technique we can use under the hood. So let's see what this technique is. They talk about you can write an iterative code. Oh, by the way, they talk about a procedure versus a process. Now, what is this distinction? A procedure is the code you write. A process is the code that runs. It's kind of obvious that that's what happens already, right? Because the compiler takes a stab at your code, the JIT compiler then comes through. So eventually what runs is transformed code already, right? So the code you write is what you wrote is a procedure, and the one that runs in effect is the process. Now, what they talk about in the book is they say, what if you write an iterative procedure and you run it as an iterative process? And we did that a few minutes ago, right? We wrote an iteration, we ran it as an iteration, life is good. We could also write it as a recursive procedure, and then we could then, of course, run it as a recursive process. And that's what we did, at least until the value became too big, we were able to run it as a recursion. But where really big gains come in is, if you can write it as a recursive procedure, but somehow quietly, it runs as an iterative process. Now you get the best of both worlds, right? You write as a recursion, so it's very expressive. You can still have the party with your friends, but it runs as an iterative. This is like finding that magic pill where you can eat all you want and never at your midsection. If you find that pill, please let me know. I can benefit from it a lot. I need that for the amount of travel I make. I definitely need it. But in this case, we have this pill in this case of Scala, because Scala says, if you honor the recursion as a tailed recursion, then I can take care of this for you. So notice what I'm going to do in this case. I'm going to go back over here to this code, and Let's go back to 5 here for a second. But in this particular case, I'm going to change this just a little bit to say, I'm going to take a value of n, but I'm also going to take a factorial as an input value as well. And then in this case, of course, if n is equal to 1, return the factorial. But if otherwise, go ahead and return factorial of n minus 1, and then n times the factorial itself. So we did a preemptive strike here, and we said we'll perform the computation first, and then throw it as a parameter. Now notice that this became a tail call. Let's step back for a second and take a look at this one more time. The function I had a minute ago, if you go back and look at this code I had a second ago, notice the last call that is being made in this factorial function is the call to multiply itself. So in other words, the factorial says, I have to pause right here, take the value of n on one hand, and wait for the result of factorial n minus 1 before I complete the operation and return. So it's got to hold the stack and climb on the stack to the next level. On the other hand, with the little refactoring we just did, what we did in this particular case is we instead said we're going to take this value of the factorial right now, so factorial of n minus 1, and then we will do the math right away, right here in this code, and then pass that value as a parameter in the parameter list. So as a result, the last operation that's performed right now is the call to the factorial itself. In other words, as soon as the factorial is computed, there is nothing more for this function to do but to return the value. The compiler can be smart enough to say, wait a second, if all you're doing is standing on the stack, waiting for this result to be received only to pass it down, why don't you step down from the stack and wait for the result? So in other words, very quietly under the hood, it can convert this from a recursion into a very simple iteration. And this can be done with compiler support fairly well. So if I go back and write this code for a second now, notice that the same result as before, but on the other hand, this became tail call recursive. Let's challenge this a little bit to see how this is going to work. So if I increase the value like I did before, notice that in this case we did not get a stack overflow exception. Of course, it gave a value of 0, which we'll fix in a minute. That's because of an integer overflow. But notice it's not really having a problem in the stack at all. So what's happening? What's happening in this case is the compiler very quietly takes this factorial and recognizes this is the last call in this function itself. So this is tail call, and as a result, can optimize for tail call recursion. And so quietly transform this entire code into a simple iteration under the covers. So as a result, it becomes a while there is more code to run, keep running it. And as soon as you get a result, return it, right? It just becomes a simple iteration. And as a result, of course, I want to make this work properly. So I'm going to change it to a big integer in this case. And of course, if n is 1, I want to return the factorial. Otherwise, I want to continue with the value and return the result in this case. So in this case, of course, this is a factorial, and this is going to be a big int of 1, which is the value that I want to send to it initially for this to work properly. So let's go ahead and change this to, of course, the result is going to be a big int as well. So in this case, we are running this factorial with a large value, 50,000. And of course, the recursion is taking a little longer here. Don't try to memorize that result. You don't need to know this. But that's an example of how the tail call optimization really took place. So it's already baked into the compiler. Now you'll say, all right, this is nice, but anytime we hear the word magic as programmers, we don't like it, right? Because later on, you may come and change this code a little bit, and it no longer is tail call recursive. How do you know that this is broken? To solve this problem, Scala provides a little annotation for compiler support. So you can say Scala dot, in this case you can say annotation dot tailrec, and in this case, of course, it'll look through your code and make sure that this code is actually tail call optimized. Now what if I don't have this code as tail call? What's going to happen? So as you can see in this case, if I go back and put a 1 times factorial and try to compile this code, it yells and screams at me and says, what are you smoking? This is not tail call optimized. Why are you putting tail call recursive on the top? So you can see that it kind of checks and balances it. So you can use the annotation to emphasize that the code is really tail call optimized. And if it is not, it's going to give you a compiler error, and you can recover from it. So let's look at this for a second. We made a little bit of improvement in this code. Now that we made this improvement, we can go for a large value of input as well, and we are able to use recursion. But there is one disadvantage in this code. What do you think we lost? That's correct. The simplicity for the caller is gone, right? Especially. So as a caller now, I got to send 2 parameters. Now you're going to say, what if I send the big int 2 here? No, sweetie, you cannot send 2. Can I send 0? No, you cannot send 0, right? All this unnecessary complexity. Well, what can we do to eliminate that complexity? Well, here's an idea. Why don't we change this to an implementation for a second? Let's change this to an implementation for a second. Then we can write a function called factorial, which takes a number, and then it can simply return factorial implementation of number comma big int 1. So we can really move that into it, and now we can simply say call factorial with just 1 parameter rather than 2. What do you think? A notch better, but you always have this one colleague who comes to you and says, can I still call it? So if you don't want somebody to call it, you don't want them to ever call it, what would you do? Make it encapsulate, right? The other day somebody said threaten him. No, you don't want to go to that extreme. So you want to make it encapsulated. Well, how do you make it encapsulated? Oh, write a class. Well, wait a minute. We don't need a class, though, do we? So here's an idea. Why don't we grab that function for a second and totally move that function into this function itself? And in other words, because it's functional style, we can have functions within functions as well. Nothing stops us from doing that. So we encapsulated this function not through the class approach as we normally do, but more of a functional style by having the function within this function itself, as you see here. So that's an example of how we can use the tail call optimization. And tail call, of course, is relying on the support by the Java compiler, sorry, the Scala compiler to do this. The Java compiler doesn't support this, and as a result, the bytecode doesn't quite directly support this either. So there is some limitations to how far you can go with tail call optimization. If it is too big a function, the tail call optimization may not work. Too many returns, it says, wait a minute, this is too complex for me to analyze, I'm not going to do it. And you can also, it doesn't do what is called a trampoline call where A calls B and B calls A back and forth. But Scala also provides you a class called tailrec, which you can use to provide the tail call optimization in a trampoline as well, and you can certainly do that. I was inspired by this, by the way, and also I know how trampolines are implemented in Groovy. So over the holidays, I really got excited. I wanted to write a book on Java 8 Lambda expressions because Java 8 is just around the corner. So as I was writing the book, I said, wouldn't it be so cool to show how to do tail call optimization in Java? So the first thing I did was I looked to see if Java supports it. It doesn't right now. So I decided to implement it. And I kind of set out to do what Scala does at the tail call, tailrec classes. But I actually found out there's actually other better ways to do this in Java. But this is another point I kind of wanted to make, is one of the reasons I really like to learn some of these languages is not that I would program in these languages all the time, but just programming in these languages gives us so many things we otherwise don't. And then when you go back to programming in the language you currently program in, you tend to kind of sit there and figure out how to really bring in certain concepts that usually people cannot do so easily in those languages. But being equipped with some of these things, I think we really are expanding our ability to program in these other languages as well. So it's a lot of fun to learn some of these things, whether we program in them all the time or not. So let's talk about classes a little bit. Classes are cute in Scala. Let's talk about writing a class for a minute. A public class car, a private int year. Oh, I forgot to put final. I'm writing Java, obviously, right? And then I would say private int miles. Then, of course, public int get year. And then, of course, in here we would say return year. And then public int get miles. And then, of course, return miles. And then, of course, we would write a set method, isn't it? Public void set miles. This is one of my most favorites. This has to be named miles also, right? As if there's no other variable on earth. And then this dot miles equals miles. If I ever find this, usually I strangle the person who writes it in my code, right? So we do all of this in Java. I know what you're thinking. You're saying, wait a minute, I never do this in Java. I only declare the field, then I gently right-click on it. And before I could blink my eyes, the IDE vomits the rest of the code, right? So what we are saying is, not only we want a language that is not doing the right stuff, but we also have to invent IDEs that constantly vomit. And then what do we have to do? Step over that vomit all the time, right? It's like, oh, don't step on that, right? So why do we have to deal with this IDE vomits in the code? What if the language does these things for us automatically? Let's write this in Scala. How many times do you make your class non-public, by the way? Not a whole lot. So why not just say class car? Hey, can I make it public? That's okay, it's already public. No need to say any more. Val year is going to be an integer. Var miles is going to be an integer also. Great. What did we do? We have written a class. But I need a getter for year. Done. I don't want a setter for year. Okay, no setter for year. It's a val. I want a getter and setter for miles. Done. I want a constructor for the car class. Done. I know you're in a panic mode now. You're like, what? If all that is done, what do I do? Go home, right? Enjoy the evening. You don't have to write stupid code. So you can simply say car1 equals new car. Year is 2013, miles is 0. And you can say car1.year, print the car value. So the class is already written for you. You don't have to write the class. You don't have to write the constructor. You don't have to write the setters and getters. Of course, it doesn't follow the Java Bean convention. You could if you wanted to by putting annotations on it. But all that is done for you. What if I want to write some implementation here? Well, in Scala, you don't really write classes. In Scala, you kind of write constructor, very much like JavaScript. In JavaScript, you don't write classes. You write constructor. And that becomes a factory to create objects. So very similar concept in Scala like in JavaScript. You are writing this little constructor. In fact, if you will, you can simply over here say created, for example. Notice I say created. And in this case, I'm going to say val car1. Let's say val car1 and equals new car 2013. And I'm going to specify 0, and you can see that created got called because it's a constructor evaluation. Now I can write a function here, define drive, which is going to take a distance I want to drive this car in, and I could say miles plus equals, let's say, the distance. And I could print out here for us to see, I could say driving, for example. So in this case, of course, I could say car1.drive 10, and then of course, I can print out car1.miles to see if the value of miles has been changed. Now notice how I put semicolon here just to show that it's still possible to do that. Or you can say car1 drive 10 and you can do that as well. So you can go scale up all the way to high ceremony, or you can kind of start removing a lot of stuff around it, and that would be just fine as well. And Scala is quite happy with that to call it. So again, a lot of ceremony removed around the code. You can focus on essence. So you're writing a primary constructor. Now, of course, a class could have multiple constructors. In that case, you can write what are called auxiliary constructors within this class, or within this primary constructor. And then these auxiliary constructors, there are some ground rules you have to follow in Scala. The auxiliary constructors are required to call back into the primary constructor, and the primary constructor is the only one that can call the base constructor. So it's kind of like a funnel, if you will. It kind of takes all of these through the constructors, the primary constructor, which then feeds to the base class. Why? Because it removes duplication in code. It removes a lot of errors that we normally introduce in writing constructors by requiring this kind of channel through which we call these methods. And of course, in Scala, classes are pure. Now, what do I mean by they are pure? In the case of Scala, by the way, you don't have static methods. No, don't leave the room yet. It's much better than that. Why? Because remember what we talk about in programming. We say separation of concern. And we all say, amen, brother, that's great. We have to have separation of concern. And then what do? We sit down and say class and then we put instance and static in it. And then instance method and static methods. What is that? Separation of all the concerns in one place, right? So that is not a good separation of concern at all. Why? Because we are dealing with instance-related stuff and class-related stuff in one place, and that becomes a pain in the neck to deal with. Go ahead, please.
I'm sorry, I wanted to ask.
Absolutely.
After the death.
Right. So the question is, if I have it right here, you're saying?
No.
Oh, pardon me. Over here.
No. Yes, there. With that also.
Sorry. So here too. So this is basically the entire body is part of a constructor. So in other words,
Created here too. Okay.
yes.
I see.
Yeah,
I see,
yeah,
I see.
absolutely.
The entire body.
The entire body is a constructor, except there are parts of it that get stripped out as the members of the instance that you're dealing with. Like a pearl, in a nice way. Yeah. So again, you know, if you ask me, I would not do that. Right? Exactly. So there's a difference between can I and should I. So there's a lot of can I, but should I is usually not an answer. Right? So that's something you wouldn't exercise normally. So the real beauty of this is, so static things are really evil to put in a class. There's another problem also. How do you create a singleton in Java? You could write a private constructor. Now, the minute you write a private constructor, one of your colleagues comes to you and says, hey, look at these two objects I created. You're like, darn it, how did you do that? Oh, I used reflection to do it. And now you're like, okay, let me go plug that hole, right? And then tomorrow you walk around proudly and say, now you cannot. And he says, what about these two objects? Darn it, where did you get those from? Oh, I serialized and deserialized it. Darn it, let me go fix it. By the way, there's a name for this. This pattern is called Scotch tape-driven development. You put a little tape on it, it peels a little bit, tomorrow you put more tapes on it. Well, it turns out, by the way, singleton is a pattern you take 5 minutes to learn and years to get it right. And in fact, it's so bad that Java figured a way to solve it. A right way to do singleton in Java, it really makes me cringe, is to write an enum. Because enums implement singleton fairly well. But that kind of smells, isn't it? What enum to write a singleton? Well, what is the reason why we prefer that? Because singleton is so hard to do, it's better to leave it to the class loader to do it in the first place. So Scala says, all right, if that's the right thing to do, why don't we provide it for you? So notice what I'm going to do in this case. I'm going to have a class called car here. Let's just remove all of that for a minute. I'm going to create an object called car. Now, notice in this case, in the case of Scala, you can define a singleton using a word object. Now, object basically indicates a singleton. Now, it so turns out you can just have a singleton by itself. Or you can also have a singleton with the same name as a class. And if you do, by the way, this singleton has a special name. It's called a companion object. A companion object has full access to the object for which it's companion to, the class for which it's companion to. So in this case, I'm going to define a method here. We'll call it as create for a minute. And the create is going to take a year, let's say, as a parameter. And then I'm going to simply say return new car given year and 0. So notice I can simply say car1 here. And I can simply, in this case, say car.create. And then I can say 2013 to create a car object. Now in this case, of course, I can print car1.year. And I can also print here car1.miles to know what the value of miles is. And so we kind of wrote a wrapper around this. Now car.create essentially is like a factory that is creating the instance for us, but the car itself becomes a singleton in this case. We can go a step further with this. I can call this a little bit different as apply, and then I can then call this as apply. So a little apply method. Well, the word apply kind of comes from functional programming where we are applying a function, meaning we're invoking a function, we are executing a function. Now, a little difference, but where does this take us? Well, the apply has special meaning in Scala. We can simply drop it in this case, and this kind of becomes more like a factory, if you will. So when you just apply this method without any notation, it implicitly calls an apply method, and the apply method has some special meaning. Now, if you understand the apply method a little bit, now this changes the way you look at things. If you have an array of objects or a list of objects, if you will, so numbers equals, let's say, a list of 1, 2, 3, 4, and 5, a bunch of values. I want to get the first element. How do I get the first element? Numbers, a parenthesis 0 gives you the first element. You kind of wonder, why do they have a parenthesis instead of the fancy square bracket? Now you know the answer. It's because it's implicitly calling the apply method under the hood, and as a result we are using a short form notation for doing certain things. So a lot of these hidden gems are in Scala, and it takes a bit of getting used to, but once you kind of understand the nuances of what's happening, it's much easier to write this language itself. So we talked about quite an interesting set of features already, but I want to talk just a little bit more about function values. We used function values mostly, but it would be nice to know how to receive them and process it. And then I'll talk about traits and chaining traits as the last two things I want to talk about. So let's talk about function values for a minute. Let's say we have these values of prices given to us. So prices equals, and then let's say we have a bunch of prices, right? So 10, 15, 20, 25, 30, 35, and 40. So our task on hand, we are told to go total all these price values. You say, I can do that. So let's go ahead and write total prices. And total prices takes prices as a parameter. This is going to be a list of integer values given to us. And what should I do within this function? Let's say total equal to 0. We could use a fold left method also if you wanted to, right? We could say fold left or reduce method. We could use all of that, but let's keep it simple here for a minute to keep our focus on the other part we want to deal with. So I'm going to return the total from here. So in this case, I would say price in prices. And what do I want to do with the price values? We could simply say total plus equals the price value itself. Let's go ahead and call this method to make sure it's working. So total prices, and I'm going to send the prices values over here. In fact, let's go ahead and move these prices below here so the context is very close to where we are using it. There we go. So that is basically a value being totaled. So you get this done very quickly, and the requirement given to you was write a function that totals all the prices. So you're done. Well, as the fate may have it, your colleague comes to you and says, I also need, by the way, in addition to this, another function that only totals prices greater than 25. And you ask your colleague, do you mean total prices over 25? And your colleague says, yep, that's exactly what I want. So you're sitting there and wondering, how do I write that function in addition to this function? And you stare at this for a minute, and then you tell yourselves, there's a reason why they created copy and paste, right? I mean, if nobody should use it, why would they create it, right? So you copy. In fact, this is so compelling, they gave shortcut keys. How nice is that, right? Control C, Control V, right? And so you say total prices over 25, and then simply you say if price is greater than 25, then total, otherwise not. So you got that implemented very quickly. Well, unfortunately, your colleague comes to you and says, I also need another function that totals prices under 25 also. Now you know you're in trouble because you copied and pasted the code one more time already, and you know that copying and pasting code a third time is criminally negligent. But nobody is looking right now. So you copy and paste it one more time, and this becomes under 25, right? And of course, in this code, you say under 25, and you get this working really quickly so you could leave. But as you leave the building, your guilt kicks in because you know that this is not what you really signed up for, right? This is really bad coding. So you pull over to the nearest coffee shop, you're frantically trying to refactor this, but as fate may have it, a bunch of your friends show up and say, what are you doing? And before you could close the lid, they take a look at it, and they get to know your dark side, right? And they no longer want to hang out with you, and they don't return your phone calls anymore. How really life becomes, right? No, we never want to do that. We want our geek friends. So let's step back for a minute. Let's get back to the code where we were, and then rewind the time. And this is when we have this one function on our hand, and this one function is working, right? So our colleague comes to you again and says, hey, I need a favor from you. I need one more function from you. What do you need? I need total prices over 25. Oh, that's what you want. Yes. Well, I'll get back to you. So we're sitting down and saying, how do we really make this work? Well, a little bit of refactoring is needed. So let's not do that right now. Let's instead go back here and say, well, I want to total values, but it turns out that I don't want to total all the values. I want to total only select values. Sometimes I want to select all the values. That's perfectly fine. So I'm going to write a selector. Now, what is this thing called selector that I'm specifying here? Well, a selector, by the way, is going to select. Now, what are you going to give to him to select? A price, which is an integer. And what is he going to give you back? A Boolean. See how easy it was to write that. So a selector is just a function. So it's a function. Why? Notice prices colon int square bracket, list square bracket int. So prices is an object of type list. Selector is an object of type function. How do we know? Notice the mapping which we specify here, right? After all, a function is a mapping of an input to an output. So it is just a mapping of a selector. That's all we have. So now that we specified it, we are simply saying if the selector is accepting the price value, then total, otherwise no. So now we can come back here and say, I want to take a value as an input, by the way, price, and I want to accept everything given to me. So I'm going to simply say true as a return value. So this pretty much accepts all the value given to it. Now your colleague says, I want a function that totals all the values which are greater than 25. You tell your colleague to go write it himself or herself. So price is going to simply say price is greater than 25, and then you can say go ahead and only total values greater than 25. Now if you want a value which is only less than 25, not a problem. You can simply write that and say less than 25, and you can simply leverage that code we wrote. So in other words, we made total prices a higher order function. In other words, the total prices says not only will I accept a value like I did before, but I will also accept other functions like in this case. And if you really think about this, what did we just do? We quietly implemented the strategy pattern. Look at the difference. In Java, if you want to use the strategy pattern, you hold a corporate design meeting. Here it just works as simple, right? So that's a very lightweight approach to implement a strategy. You're not really forcing yourself to create interfaces and hierarchy of classes. It just works. So that is an example of how you could use a more of a functional style of coding. With this said, let's talk about yet another. Oh, please, yes, please. Yes, yes, you can do that as well. So you could use default parameters if you wanted to. You could do that, or you can just overload it. Either way is fine. Yeah, absolutely. Functions can have default values as well. Right, so in here, right? So equal to, you won't put Boolean, but you'd have to put a function, actually put a function itself in this case. Yeah, absolutely. So given this, let's talk about some other feature that we want to implement. Let's talk about multiple inheritance. You're thinking, no, let's not. Well, how many of you have implemented multiple inheritance before? Oh, wow. You all have dark past, right? You all programmed in C++. Oh, I mean, secretly, I would say that's a language I really like still. But how many of you who raised the hand want to go back and do more multiple inheritance tonight? Not a single person raises the hand, right? Why? Because multiple inheritance is like a gorilla. It is cute when you see it in the zoo, but you don't bring it home, right? It topples your furniture, causes havoc, right? So, well, to be fair, the problem is not with multiple inheritance. It's with way C++ implemented it. Let's get to that in a few minutes, but let's get back to some other concept. Let's say for a minute we are writing a class, and the class is called human. And the human has a name over here. We'll give a string name. We'll put a val. And then, of course, I want to say here, define listen. And I'm going to say listen is going to simply print out print line. And I'm going to say I am, we'll put a name here, listening, right? So you could use new Scala facilities to put that into a little dollar symbol, but I'm not going to go there. So let's create a variable sam equals new human, and then we'll create a sam variable, and then we'll say sam.listen. So here we go. we have a little human class with a listen method. But wait a minute. What does a listen method have to do with anything? Who listens, by the way? Sam listens. There was actually one guy in the front row in a couple of weeks ago, and he said, wife? And we all kind of looked at him and laughed. And then after a few minutes, he said, well, I've been married for 2 weeks. It's like, okay, you're still in that honeymoon phase, right? You will know better very soon. We all have we all have very contextual hearing, right? I always pretend that I hear. My lovely wife, she's wonderful, and she talks to me all the time when I'm working in the kitchen. And life was in harmony, right? She says, you're so nice having you in the kitchen. Look at you, you're working and listening to me. Well, except one day, there was suddenly a silence. And I kind of looked up, and she was staring at me. And I said, is there a problem? And she said, I asked you a question, and you haven't answered it. And I'm not going to repeat the question for you, but I need an answer. I knew I was in trouble, right? So I had to really work hard to get the question out of her before I could answer. But now she's gotten better. The other day I was working in the kitchen, nodding my head and working away, and suddenly, there's a ting, there's an email. I started replying to email, and halfway through it I realized she sent me the email from the kitchen. And she said, that's the way I get an answer from you. So I got busted, right? So we all have this selective hearing from time to time. But one who listens, by the way, is a friend. Wouldn't you agree? A friend listens to you, right? So a friend listens to you, but we kind of put this listen in the human, assuming that the humans do listen. But there's one friend who always listens to you and never speaks back to you. Dogs. How awesome it is to have a dog. But how do you do that? Hey, I want to inherit the dog from human because I have the listen method in the human. Dogs don't like it, right? So what's the Java answer to solving this problem? A mammal. Only a stretch. Interface. We have a friendable interface. Now we have a friendable interface with a listen method, but now we have a problem, right? Human has a listen and dog has a listen, which is duplicated. How do we remove the duplication now? So we create an abstract base class, right? But how do you reuse the abstract base class? So we have an interface in the top. The two classes will then delegate to the abstract base class. And that's a lot of work, isn't it?
And how about microphone?
A microphone listens to you.
It gets worse and worse.
Yeah, it could be. Yeah, it can get worse. So if that is the pattern we're going to follow, why can't the language do it for us automatically so we don't have to put the effort to do it? Let's see how. So I'm going to create a trait. So what is a trait? A trait is kind of like an interface to begin with. So trait friend, and my trait is going to have a listen method. A trait is an interface except if it has an implementation. Then it's buy one get one free offer, right? There's an interface called for the trait, and there's also an abstract base class being created for it also at the same time, right? So we got two of the things together. So given this, I'm going to say extends from friend. So in this case, of course, I'm saying, oh, this of course should have a name. So name is going to be a name, which is going to be a string. And I haven't given a value to it at this time. So it worked. Let's go a step further. We say class animal. And the class animal has a name. So it's got a name here. Class dog, which override a name, which is a string. And it extends from animal. And let's go ahead and say this contains the value name. So let's start with this. So val buddy equals new dog, and I'm going to say buddy, and buddy dot listen. Well, that doesn't work. Why? Because dog is not a friend yet. Let's with friend. So it's a little bit of a inconsistency here. Because human doesn't inherit from anything, we use extends. Because dog inherits from animal already, we use the word with. So notice how we were able to bring that listen into this fold by simply using a with friend as a trait. So what did it do really? What it did was it created an interface called friend. It created an abstract base class called friend. So you got two things now. a friend interface and a friend abstract base class. It injected into human class the reference to the abstract friend implementation, and it also injected into the dog class the abstract base class calls into it. In other words, it mixed it into those two automatically, so the method is available on both these without we having to duplicate it. So far, so good? Let's continue. Yep, go ahead, please.
Can you do multiple?
The answer is yes, but let's come back to that in just a few minutes, please.
Is the name supposed to be the same thing?
Yes. So in other words, in this particular case, it says you are putting a constraint that this can be mixed in only into classes that have a name property. So it's a constraint you are propagating. You're saying, I'm a trait, but I will only accept being mixed in when you have this property brought in. So the friend doesn't have a name. The human has a name. But there you said, oh, by the way, I'll only get mixed in if you have that name, not otherwise. Please. Not quite the same, by the way. So the question is this very similar to the default methods being introduced in Java 8? Not quite exactly the same, because the rules are fairly different for how default methods in Java are implemented compared to this. You could say that there's an overlap between them, but they're not a one-on-one substitute for each other. The default methods were really introduced in Java 8 to evolve interfaces that already exist for the past 15 years. The intent here is very drastically different. So there's a bit of an overlapping area, but the intent is very different. This kind of takes you into the decorator pattern area we'll see in a few minutes. The default method quite doesn't solve that particular problem. Good question, though. Let's look at this one more time. Let's say for a second I create yet another class over here. Let's say a class that I'm going to create here is the class called cat. So I've created a cat class. And in this case, of course, I'm going to create a cat. So let's create Alf, which is a cat, scary cat. And this is going to be, I'm going to call alf.listen. Will this work? No. That's because cats are not friends, right? In fact, cats kind of look at you and say, why are you back from work? Why don't you put some more food around and go back to work, right? Anybody with a cat? Is your cat friendly? Very friendly.
Cats are like,
I'm
they're friendly, they're picky who they're friendly.
Right. Ron, I'm sorry to deliver this news to you. You're in denial. But you're a nice guy. You've been really interactive sitting here. So I'm going to try something, but no promises. Okay, but I'll try. Ron, I'll try. So
Appreciate the intervention.
absolutely. I'll try, but no promises. So Alf is a lost cause, so let's not even mess with Alf. So Ron's cat. Would you share your cat's name with us, Ron?
You want to go?
Spell for me.
Fiomaghan.
No wonder. Okay, so cat. Okay, dot listen. Sorry, we tried. But one last hope. One last hope. So what did we do? Cats are evil, by the way. But Ron's cat is special. In fact, Ron, would you say it's one of a kind?
Very much.
Absolutely. So in fact, it really is. If you look at what type the cat object is, it's not an object of cat type.
See, but the issue is, she doesn't listen to me, but I'm supposed to listen to her.
Oh. So in this case, of course, you have an anonymous inner class. And this anonymous inner class extends cat, by the way, and implements friend. So it is one of its own kind. Cats are not friendly, but Ron's cat is special. So not only can you mix in a trait at the class level like you did in the dog case and human case, you can even inject it at the instance level if you wanted to, right? So this gives a pretty powerful traits, and all this is compile time programming in this case, of course, but you're able to extend the behavior. So one last example I want to give you goes back to your earlier question. Yeah, go ahead, please.
How do you refer to the type?
How do you refer to the type? You can refer to it as a cat. You can refer to it as a friend. Because it's anonymous. So you can only refer to them as one of these two, cat or a friend, please.
So if you on line 25, you just duplicated that. If you just had
There could be two different types as well. We're going to see mixing of multiple things in a few minutes. We'll get to that. Somebody had a question here, I think.
Can you demand that a cat is implemented with friend as an input parameter?
You should never demand anything to a cat, but nevertheless. The answer is yes. So if a function requires a friend, you can send this cat to that. Ron's cat can be sent, but not cats in general. Let's do that real quick before we go to the next example. So for example, if I said over here, just as a quick note, if I said, seek help from a friend, and let's say friend over here. And in this case, of course, I'm going to simply call friend.listen, right? So that's all I've done here. Let's remove this listen. Let's remove this listen here. And then let's also get rid of Alf. So over here, I could say seek help Sam. So obviously, I'm sending Sam to the method. I can say seek help Buddy, and of course, seek help Ron's cat as well. As you can see, we could send that. But I cannot send a cat in general. So seek help new cat. Oh my, I cannot do that, right? So that's not allowed because cats are not friends. So let's get a step further. We looked at traits. But let's get back to the problem with multiple inheritance. The problem with multiple inheritance is twofold, right? What if methods collide with each other? That's a pain. The other problem is the diamond problem, meaning that you have a base and then they have common base. How do you deal with it? What if the interfaces decide to collaborate rather than collide? Then that wouldn't be a problem, isn't it? So the way this works is the traits actually line up next to each other like a train. And then when you call a method on a trait, it can pass the call to the next one, and then they all can work with a cumulative effort. Let's take a look at an example. I need about 5 more minutes to get through this. So let's say we have a writer, and I'm going to make this an abstract writer. So abstract writer. So this writer simply has a method called write, which is going to be a message string. That's all I'm going to take, right? Not a whole lot of implementation in it. What am I going to do? I'm going to have different types of writers on my hand. Let's say we have a class called string writer, which simply is going to extend from writer. So in this case, of course, I'm going to write the write method, which takes a message as a parameter. And I'm going to simply say here, all that I will do here is to say target.append, and I'm going to append the message. Well, what's the target, by the way? Let's say the target is just a new string builder, let's say. So that's good enough for now, right? So let's also write one other method, override the toString method. And all that I'm going to do in the toString method is simply say target.toString and return the result from it. That's good. Let's give it a try. So I have a writer and I have a string writer, but imagine I could have different types of writers. A string writer, a file writer, a socket writer, encrypted writer. God knows what other writers I can create, right? Several writers I could create. But I want to use this writer. So write a method called writeStuff, which takes a writer as a parameter. So there's my writer. And in this case, what I'm going to do is simply write out writer.write, and I'm going to write this is stupid. And let's print it out. So I'm going to print out the writer. So let's go ahead and try this out. So let's call writeStuff and send new string writer and see how this shapes up. So it wrote this is stupid. Great. Now let's say a few minutes goes by, our requirements change on us. They not only want us to write stuff to this writer, but they also want to convert everything to uppercase and write it. So they want both the functionality, to write all the text as it is and to write all in uppercase. Well, where do I put this new function to write in uppercase? Here's an idea. Why not put it in the writer abstract base class? What do you think of that idea? Not a great idea, right? Because it pollutes that abstract base class. Next thing you know, you come back from vacation, there's 20 methods in it, right? No, you don't want to do that. Hey, I can put that in the string writer. What do you think? Not a good idea, because it is not available in these other 20 different types of writers I have. So it looks like a good candidate for a trait. So notice what I'm going to do now. I'm going to go back here and say trait, uppercase filter, and in this case it extends from the writer. Now I want to kind of caution you, the extends here is a little bit confusing. It really doesn't mean extends. It's more like a constraint. You can only use this uppercase filter into stuff that is a writer, right? It's a constraint you are placing. Now I need to write a method called write, which takes a message as a parameter. And what am I going to do here? Message dot to uppercase. Great. But where does this go, by the way? Well, obviously, I have to write it into somewhere. Where do I write it? In other words, I need to write it into where do I write it into? Well, I don't know what where is at this point, but I know that it's got to be to the object in my chain. Now, how do I specify the chain of the object? They decided to use the word super. The word super doesn't mean super. The word super here means the next guy in the chain. So it's a little bit confusing. Normally we use the word super for an inheritance hierarchy, whereas here it's a trait hierarchy from right to left, if you will, right? From right to left. All right.
That's the only time you can use it?
Say that again?
Is that the only time you can use it?
No, you can also use super for the regular inheritance as well. So having done this, how would I go about specifying it? Here comes a deadly combination of word called abstract override. The best thing about this is to not look at it again and forget about it, because it's a bit confusing. It simply says abstract because I want you to provide the right method in your implementation, override because I am overriding a method that's already in the contract. Don't think too hard about it. It gets a little frustrating. So anyway, we wrote that method. How would this work? Let's go ahead and try this. So now I'm going to say write stuff new string writer, but you know where I'm going with this, with uppercase filter, and now you can see that it actually nicely put it in uppercase. How did this work? The request to write, by the way, goes to the uppercase filter, which converts a string to uppercase, and then forwards it using the super call to the string writer, which then writes it down. Now let's do one more thing, by the way. Well, it turns out that I had a discovery which was very sad. I came to know that I'm a bad guy. It's always kind of hard to realize that, right? I travel a lot. I hang out with programmers like you all, so what do you expect, right? Just kidding. So I go home after one of my trips, and my little boy runs to my wife and says, "Mommy, Daddy is a bad boy." And my wife, whispers to my kid and comes back to discipline me, and she said, "Did you say a bad word to the child, to the children?" I said, "Bad word? What did I say?" And she leaned over and said, "Did you use the S word?" I said, "S word?" And then I whispered and said, "I would never use such an S word. Not that." And then she whispers back, "Did you say stupid?" I said, "Of course I said stupid. Don't say it again." I said, "What's wrong with stupid?" She said, "Look, I've been teaching the children to have manners. They cannot call people stupid." Is that true? You can call people stupid? I mean, we do this all the time at work, right? That's stupid, right? And I'm like, okay, I will not say it again. So I had to put filters on me, right? I mean, you couldn't say stupid in front of children. I didn't know this. So this is kind of troubling. So trait, profanity filter, right? And profanity filter extends writer. And what do I do here? Abstract override, define write message string. And what am I going to do in this method? Super.write, message.replace the word stupid with the word, right? So that is my profanity filter. So now write stuff, new string writer with profanity filter. Much better, isn't it? Well, let's give this one more try. You know where I'm going with this, right? So I'm going to say write stuff, new string writer with uppercase filter with profanity filter, all the three together. How about that? So run that. Awesome, isn't it? But of course, you already noticed one problem here. Because the request goes to the rightmost object, and then it goes through the train of objects one at a time, the sequence matters a lot. So as a result, if I try now, write stuff, new string writer with profanity filter, with uppercase filter, notice what happens. It doesn't remove the content. But don't worry about it. This is perfectly fine. Because the other day I was very angry, and I screamed, "This is stupid!" And immediately my little boy's eyes widened, and my wife was like, "Daddy is upset right now, be quiet." So this is perfectly fitting the domain, right? So you can see how the chaining of object works, but the proper order of chaining makes a big difference too. But all that you did right now is just implement the decorator pattern, as you can see, right? Very, very smooth way of implementing just by using traits, which is already baked in, and it can be used fairly effectively. So that is about chaining of traits and how that's baked in. There are all these interesting features that the language provides. It still follows the Java semantics, but it brings to the table enormous amount of conciseness. There's a lot more conciseness than I have covered here, but I hope that that kind of gives you an idea of what you can do. But the nice thing about this is it's not an all or nothing proposition. It's a language on the JVM. You can compile this into bytecode. You can layer your architecture in a way that you can use Java where it makes sense, especially in legacy applications, and then reach into Scala where it makes sense in layers. And then you can build part of the system with Java, part of the system with Scala, and then bring them together. And places where I find this to be extremely useful is when I want to do XML processing, for example. Scala has really nice features for it. When I want to reach into functional style, you can either wait for Java 8 or you can use it right now in Scala. You can use this where you want to use good pattern matching, for instance, or you want to use the functional style as we saw here, or I haven't even scratched the surface of concurrency, where you can use this enormously capable solutions to either implement an actor-based concurrency or use parallel collections and stuff like that. So the beauty of this is it is a language that's there, but think of this, a lot of times when people ask me, how do you use this? Think of this like you use Spring or Hibernate. It is a language that you throw in with a certain capability, but at runtime, it's a question of having a few more jar files in your class path, and then you can start mixing them in. And I've seen this used pretty effectively in organizations where concurrency is very important, or they have a very heavy lifting to do, like a lot of XML processing to do. These are the places where you will be able to leverage. The other benefit I see a lot about this is I learn languages primarily for one reason, to use them, but more important, to go back and program in the languages I program in a much better way than I did. Because these languages don't teach us a syntax. In fact, it's the wrong thing to focus on the syntax. These languages teach us idioms. These languages teach us a certain way to program, a certain way to design. And I can bet you that my Java design is no longer the same. I think differently in Java, I program differently in Java. And in fact, when I got exposed to Java 8, by the way, there are certain things I'm bringing into Java 8 in terms of patterns that I've learned from these languages like Scala and Groovy and Clojure and languages like that. So just spending time on these languages really makes us better overall in programming in the languages we already program in, and also gives the agility for us. The minute we realize this is a better choice, we are quick to go adapt to it because we are familiar with it. So I hope that was useful for you. Thank you.